Today we're going to be working with the last of our transformations, which are our dilations, and you are going to notice that the dilations do have something a little bit different than the other three transformations that we've looked at, and we are going to talk about what that difference is and what that means as far as our transformations and rigid motion go. So let's take a look at our first bullet up here in the vocabulary section. It says a dilation is a transformation that produces a figure that is the same shape but different sizes. Fix that, it's kind of messy. So when we are looking at a dilation, the word that we use to kind of describe, just like we had a flip, a turn, a slide, the word that we use for our dilations is that they are a resize. So what we are doing is maintaining the shape, but we are changing the size of these figures, so we will be resizing our figures today. Now, the second bullet that we have here talks about what is called the center of dilation for a figure. So that means when you are dilating a figure, it is moving either away from or towards a center of dilation. Now, we use a center of dilation of 0, 0, which is the origin, unless we specify otherwise. Now, in this module here, we are only going to be finding a center of dilation if it's other than 0, 0. We will not be dilating if the center is other than 0, 0. We will wait till module 4 to work on that. Now, our third bullet that we have here talks about what is called the scale factor. And the scale factor is the key to a dilation. We define a scale factor as the amount of increase or decrease in the size of the figure. Now, the reason that's the key to a dilation is obviously if you are making the figure bigger or smaller, you need to know how much bigger or how much smaller you're making it. So, for example, the idea of a scale factor kind of outside the geometry classroom would be if you have something that you make twice as big. So let's say you have this item that is 5 inches long. If you make it twice as big, it's 10 inches long. So 5 times 2 is 10. Same thing with decreasing the size. So let's say you take something and you cut it in half. So let's say you have a 4 centimeter piece of board and you cut it in half. Half of 4 centimeters is 2 centimeters. So the idea of having the scale factor is really important because you need to know how much bigger or how much smaller to make it. Now, there are a couple of tricks to the scale factor to know whether you are increasing or decreasing the size of the figure, and it's all dependent on what the relationship is between the scale factor and the value 1. If the scale factor is greater than 1, so that means 2, 3, 4, 5, and so on, the figure is going to become larger. If the scale factor is between 0 and 1, so that means it's a fraction that is not improper, so something like 1/2 or 1/3 or 2/3. So if that value is less than 1, then the figure is going to become smaller. Now, on our last bullet that we have here, over the last couple days, we've been talking about something called rigid motion. And rigid motion is a transformation that takes place where the size and the shape of the figure are maintained. That's what the word rigid means here, that we are maintaining that size and shape. So let's think about the definition of a dilation. The definition of a dilation is that we are making the figure bigger or smaller. So if we think about what a dilation is and what rigid motion is, we can definitely say that a dilation will never be rigid motion because we are changing the size of the figure. Although we are maintaining the shape of the figure, the size is changing, so it is no longer rigid. So let's take a look at our first example. We have triangle XYZ that is graphed on the coordinate plane below. We want to draw and label triangle X prime, Y prime, Z prime after a dilation using a scale factor of 2. So there are two things in this problem here that are important. First of all, I am told that I am dilating the figure, which means that I am either making it bigger or smaller. And I am told here that my scale factor is 2. Now, what that scale factor of 2 tells me is that I want to make the figure 2 times as big. So I want to make it twice as large. So what I need to do is start out by finding the coordinates of the original points. So what I'm going to do is look at my points, starting with X. X is at -1, -1. Y is at -1, 2. And Z is at 1, 1. Now, when you are working with a scale factor, that is the amount of increase or decrease in size. Now, the amount of increase or decrease in size is found by multiplying by that scale factor. Now, sometimes if I have a fraction, I will divide instead just to make my life a little bit easier, but the scale factor is always being multiplied here. So essentially, what I want to do is take all of my points here, and I want to make them twice as big. So what I'm going to do is I'm going to take every point here and I'm going to multiply it by 2. So let's show that a transformation has taken place. So we're at X prime now. And I'm going to take both of these values and multiply them by 2. So -1 times 2 is -2. And -1 times 2 is -2. Now for Y prime, -1 times 2 is -2, and 2 times 2 is 4. And then for Z prime, 1 times 2 is 2, and 1 times 2 is 2. So all I've done is taken everything and multiplied it by 2, every coordinate. So let's come to our coordinate plane here. We're going to graph this figure. So X prime is at -2, -2, which is right here. I'm trying to show that prime notation there. Y prime is at -2, +1, 2, 3, 4. So right here. And then Z prime is at 2, 2, which is right here. Now I'll go ahead and connect these points here to make my new triangle. Now, one of the ways that you can check a dilation when you are done, because you are not changing the shape of the figure, you're just changing the size. What should happen when you create your dilation is all of the new sides should be parallel to the original side that it was dilated from. So my original YZ right here is parallel to Y prime Z prime. My Y prime X prime is parallel to the original of YX. And then XZ is parallel to X prime Z prime. So you'll notice that all the new sides are parallel to the original. If they are not parallel, then one of your points is probably in the wrong location. I don't usually have students using the scale factor wrong. What happens is they either forget to multiply one of the coordinates, or there's some sort of little calculation error in there, or they plot the point wrong. So if one of your sides is not parallel, just make sure you go back and check that. On this next example that we have here, what I notice is that I am talking about quadrilateral PQRS, and I'm given the vertices up in the problem, but they are not drawn on the coordinate plane. So if I have a blank coordinate plane there and I have an original figure, what I know is that the first thing I want to do is go and plot those points on the coordinate plane. So point P is at -2, positive 1, 2, 3, 4. So there's P. Q is at 1, 2, 3, 4, 1, 2, 3, 4. R is at 4, -2. And S is at -1, 2, 3, 4, -1, 2, 3, 4. And I know my lines are not perfect on here. I'm getting them as good as I can. Now, what I'm also told in this problem is that I want to dilate this figure with a scale factor of 1/2. And I know I've cut off part of the question there, so you can't see the dilate part, but you can see it on your paper. So we want to dilate this with a scale factor of 1/2. Now, thinking about what the scale factor is, remember I talked about earlier that the scale factor is always multiplied by your coordinates. Well, the other option besides multiplying by 1/2 is actually dividing by 2 instead. So you have two options here. You can either multiply by 1/2 or you can divide by 2. Now, it's much easier to divide by 2 than it is to multiply by 1/2, so I'm going to opt to divide by 2 on each one of these. So what I'm going to do, and I'm not going to rewrite the original points because they're up here in the problem, but what I'm going to do is I'm going to take each one of these coordinates and I'm going to divide everything by 2 because that's what 1/2 is. Half is dividing by 2. So P prime, -2 divided by 2 is -1, and 4 divided by 2 is 2. For Q prime, 4 divided by 2 is 2, and 4 divided by 2 is 2. For R prime, 4 divided by 2 is 2, and -2 divided by 2 is -1. And then S prime is -2 and -2. So let me go ahead and get these new points on the coordinate plane over here. So -1, +2, so that's P prime. Then Q prime is at 2, 2. R prime is at 2, -1. And then S prime is at -2, -2. I'm going to connect my points here to form my figure. And what you will notice is that once again, all of the new sides are parallel to the original corresponding sides. So we have PQ and P prime Q prime. Over here on the right side, our two sides are parallel. At the bottom, they're parallel, and on the left side, they're parallel as well. So we can clearly see that this figure is the same shape. We've just shrunk down the size to make it half the size. So on the first example on the back side of your notes here, we are going to work backwards with our dilations, and instead of giving you the scale factor, I'm asking you to find the scale factor. So I've given you an original figure and a new figure, and I'm asking you to figure out what the amount of increase or decrease in size was. So first thing I want to talk about is how we determine the difference between the original figure and the new figure. We've talked about this a couple times throughout the module, but if you are not careful, you will end up looking in the wrong direction if you do not identify your original and your new figure. So for the original figure, remember your original figure is not going to have that prime notation on it. So the original points are A, B, C, and D. So the original figure is the bigger square on the outside. The new figure is going to be the one with the prime notation, so it's going to be the smaller square that is on the inside here. Now, in order to determine a scale factor, what you need to do is look at the relationship between the original points and the new points. So what I'm going to do is I'm going to go through and I'm going to identify the coordinates of the original figure. So point A is at 6, 0. Point B is at 0, 6. Point C is at negative 6, 0. And point D is at 0, negative 6. Now, all I did was just determine the coordinates of each point on the coordinate plane by finding their x and y values. Now, the second thing that I'm going to do is I'm going to look at the coordinates of the new figure. So my A prime, my B prime, C prime, and D prime. So A prime is at 2, 0. B prime is at 0, 2. C prime is at negative 2, 0. And D prime is at 0, negative 2. Now, what I'm looking for when I'm going to identify the scale factor is what is the relationship between the original figure and the new figure. So what I notice is that this 6 right here went to a 2. This 6 right here went to a 2. 6 went to a 2. 6 went to a 2. So what I'm looking for is what is that relationship? How do I get from a 6 to a 2? Now, I know that I am looking at multiplication and division only. I am not looking at addition and subtraction because addition and subtraction do not create a dilation. It is multiplication or division only. So in order to get from a 6 to a 2, I know that I am dividing by 3. That is my pattern here. So divide by 3. Now, what I need to be able to do, once I know that that pattern is dividing by 3, I need to take that and I need to turn it into a scale factor. Now, if I were multiplying by 3, my scale factor would just simply be 3. But because I'm dividing by 3, I write dividing by 3 as the fraction 1/3. So my scale factor for this problem is going to be 1/3 because I'm dividing by 3. If I was dividing by 2, my scale factor would be 1/2. If I was dividing by 4, it would be 1/4. So multiplying creates a whole number, dividing creates a fraction. Now, this next example that we have here, we're actually going to skip this example because when I had created the notes, I forgot that we are not going to dilate from a center other than 0, 0 until Module 4. So you can go ahead and cross this one off. We'll deal with this in another module. Now, last thing that we're going to talk about is how do you find a center of dilation if it is not 0, 0. So in all the problems that we've done so far, we've dilated from the origin, which is 0, 0. In Module 4, we're going to look at how to dilate if it's not 0, 0. But what we want to do is talk about how can we move that center from 0, 0 and what is the importance of that center of dilation. So any of you that have taken an art class, you've dealt with perspective. So you've probably drawn a building where you've created a perspective point and you've drawn your buildings out from that perspective point. Well, when we're talking about a center of dilation, that is essentially the same thing. But we're talking about geometric figures instead. So what we're actually doing is we're tracing back to that point of perspective or that center from where the figure was enlarged or reduced. Now, in order to do this, and the directions ask you to find the center of dilation, you are going to need a ruler to connect the points, because if you are not spot on with your lines, you are not going to find the correct coordinate for your center of dilation. Now, if you think back to what perspective is, we know that in perspective, all of the points stem out from some original point. So in order to find the center of that, whatever the drawing is, whether it's geometric figures or buildings or whatever it is that you're drawing, in order to find the center of that enlargement or reduction, we have to go and trace backwards. So what I know about my points is that there are corresponding pieces. So for example, point C right here corresponds to point C prime right here. These two are connected to each other because point C was dilated from here to here. So what I'm going to do is I'm going to take that point and I'm going to connect it back to its original. Now, the problem is, in order to find the perspective point or the center of dilation, I have to trace out a little bit further. So what I'm going to do is I'm going to take my ruler, and I can't use a ruler on the iPad screen, so I'm going to draw these as straight as I possibly can. I am going to connect those 2 points, but extend the line out across the entire graph. So what I'm doing is I'm figuring out what are all the points that I could use to dilate C to C prime. Now, I'm going to do the same thing with A and A prime. I'm going to connect these 2 points back together to see where, in fact, they would connect to each other on the coordinate plane here. So, and like I said, I'm doing this as straight as I can on the iPad screen because I can't use a ruler. You should be using a ruler on your paper or the edge of a sheet of paper or something like that, the edge of a folder. So I'm going to use that ruler and I'm going to connect A to A prime. And then I'm going to do this one last time with B and B prime. So I'm going to connect B prime back to B and just keep extending that line, and it's getting a little bit crooked here, but not too bad. And I'm extending that line out. Now, what do we notice about these 3 lines? What you should notice is that all 3 of these lines cross at a single point right here. That point is your center of dilation, or in art, a perspective point. So what you're doing is you are tracing all those points back to their origin. Now, the origin is not the origin on the coordinate plane. The origin is that center of dilation. Now, the last thing that we need to do is find the coordinates of that point. That point right there is at +2, +1, 2, 3. So the coordinates of that point are 2, 3.